Yes, we just tried.
Okay.
Socks?
Yeah, so you see the arrow.
It just is arrows. Yes,
Okay.
arrows. It's okay.
Yeah. Well, good morning. I shall begin. Knosos is arguably the best known prehistoric site on Crete and has been the object of research at this point for over 120 years. Such a long history of research has produced a plethora of data, architectural, ceramic, and in many other media. And the site seems potentially ripe for synthetic and diachronic research. Therefore, it was chosen by Dr. Fantuzzi and myself to produce a preliminary pilot study of the use of correspondence analysis for chronology on Crete, following examples from elsewhere, some of which have been presented at this workshop. This paper has two aims: to present more fully the results of our pilot chronology correspondence analysis, some of which Dr. Fantuzzi showed yesterday. Given the sometimes dubious quality of data, we will also demonstrate today that this model can be replicated at different levels of data security. Second, to discuss in detail the creation of the dataset used for our correspondence analysis model, and more broadly, theoretical problems in working with published and legacy data, and specifically, how we overcame them in the construction of our data. To construct our correspondence analysis models, we mined the published legacy data available from KNOSSOS. Unlike other sites on Crete, such as Chronos or Moklos, which have been the subject of long-term, centrally planned and directed projects, research at KNOSSOS is best characterized as a series of overlapping but individual projects. There has never been a single cohesive program of study. Moreover, Evans' original ceramic definitions were often vague, meaning that much time has been spent in refining Evans' sequence, as well as publishing new ceramic material. Consequently, in building a synthesis, we are confronted with a convoluted and confused ceramic record with variable and uneven types and depths of published information. There are no single reference volumes, rather the dataset must be stitched together from many kinds of sources. We argue in this paper that these issues and others can be overcome through the use of an aggregated period assemblage approach, and that from this we can build functioning correspondence analysis models as proof of the concept of chronology correspondence analysis for Crete. While there are limitations in our model, for instance that it replicates the overall sequence but does not seriate individual deposits, the limited dataset we have used is, however, stretched to its limits, meaning there is great potential for this method to be applied to cleaner datasets elsewhere from Crete. First, what is contained in our dataset? Thanks to the pandemic, we decided early on it was necessary to work solely from published information. Because of the many idiosyncrasies of working with over 100 years of potential information, a truly quantified approach, including potentially important information, such as frequency data, or a truly contextual approach, selecting only fully published closed deposits, was simply not possible. Nonetheless, KNOSSOS does offer some advantages for our preliminary attempts at a chronology-based correspondence analysis. It has a full chronological sequence with data available for each phase. And this chronology is generally agreed upon since the publication of the KNOSSOS Pottery Handbook. And finally, there is much information. Over 4,000 vessels have been published to my knowledge just from the periods under our study. Recognizing these strengths and weaknesses, for our pilot, we created period assemblages from a typological aggregation of published information from Middle Minoan 3A to Late Minoan 3B. These assemblages are defined by the presence or absence of ceramic types as qualitatively derived from various publications. We generally limited ourselves to publications after 1950, since earlier publications tended to be more vaguely illustrated or vague in their descriptions for inclusion. We then qualitatively examined the publication of Knossian pottery to build up our data set, entering each type into a presence or absence database. Research on Knossian ceramics can be broadly divided into three phases, each with their own styles and research agendas. While time does not permit full detail, these are summarized on this slide. Broadly, we have the period of research prior to World War II, a post-war period of refinement and relatively steady de-excavation, and finally the current period of further refinement and gradual full publication of legacy data. Although the pace of excavation at Knossos has gradually slowed, recent projects such as the Gypsades project or the ongoing excavations in the Anataki plot promise to continue to add to this long history of ceramic data. Now we shall turn to some of the specific problems we have had to overcome. The practice of discarding non-diagnostic pottery at Knossos is most associated with evidence excavation, but the practice continued into the 1980s with varying degrees of documentation of the now lost material. This creates a bias in the data, both in the retained and published sherds towards decorated feature sherds, which much of the plain, coarse, and cooking pottery discarded, especially from fragmentary deposits. Despite this, we argue that this problem has not overbiased our dataset. We recognize that purely quantitative analysis of Knossian data is not possible at a site-wide level due to discard. However, we have countered this by the choice of a lower analytical level, typological presence or absence. Discard affects our understanding of deposit composition, not the overall typological range when aggregated across a site. It is unlikely that across the site or publications, that entire ceramic types, especially common ones, have gone missing. By choosing the aggregate approach, we believe that our typology is reliable, especially as we make, at this stage, no attempt to seriate deposits within phases. A related problem is the fact that different researchers have had different publication priorities. From the late 1950s, publication of Knossian pottery can be grouped into 3 different types, as can be seen from the graph. As is evident, the coverage of each period is not even. First, there are full or final publications, which are intended as the authoritative presentation of material, typically illustrated with a detailed catalogue and discussion. At Knossos, these can comprise excavations such as the 1980s unexplored mansion, or the publication of retained legacy ceramics, such as the Little Palace. Second, we have preliminary or abbreviated publications. These illustrate a far narrower selection of pottery to give an overview or first impression, often omitting the catalogue and level of discursive detail of the final publications, relying instead on drawings. In some cases, the emphasis is firmly on showing that only the chronologically diagnostic or decorated material, while in other cases, attempts are made to show the entire typological range. In some cases, final publications supersede the preliminary, but not always. Finally, we have incidental publications. By this, I mean publications in which previously unillustrated vessels are published, but in support of a broader point, rather than with the aim of publishing ceramics. Be it as a representative diagnostic piece for the date of a deposit, or to demonstrate the date of a particular architectural feature. These publications rarely include large quantities of material, but are included in our datasets for the sake of the completeness of the record. The foregoing summary is not exactly a surprise to anyone working with archaeological material, but seeing this graphically, I feel, demonstrates the diversity and unevenness of the Knossian ceramic record. But there is a further nuance to this. Even if publications can be broadly grouped together, there is significant variation between them in the selection of material. Prima facie, one might assume that the fuller final publications are the most useful, and this is to some extent true. However, there is, just not for the dataset being described here, what I consider to be an extremely important underlying theoretical point that is rarely explicitly explored. While features of the archaeological record itself, such as the size and type of deposits, initially shape publication choices, the traditional practices and spatial limitations of publication mean that all publication is simultaneously an act of selection and interpretation. What is included? What isn't? Why? All too often, the method that has underpinned selection is not overtly discussed. One relies on the assumption that final and preliminary publications attempt to display the widest possible range of material, but an important point remains. Archaeology as a field rarely reflects explicitly on the methodological underpinning in the production of our data and record, even though it is clear that this varies between individual researchers. Returning to Knossos, it is clear that researcher priorities have changed over time. Earlier publications are often heavily biased towards their presentation of decorated pottery, with the more plentiful monochrome and plain pottery receiving perhaps a few token illustrations. Conversely, other publications have privileged complete vessels, illustrating, in this case, far more plainware vessels than is normal, given the better survival rate typically of LM1 conical cups. Equally, even in final publications, the selection process can be uneven. For instance, in publishing the Unexplored Mansion, Popham privileged the impressive LM2 floor deposits, providing them with a fully catalogued ceramic entries and a wide selection. By comparison, as I've illustrated here, material dating to MM3 and LM1 received far more token treatment, with only composite photos, a few drawings, and no detailed cataloging, a far more limited selection. For our data set, this unspoken methodological problem raises some issues. It means, for instance, that we may not be able to be fully confident in the reliability of the records for course and cooking types in particular, especially in periods dominated by preliminary publications. We correct for this potential error by testing our data set at multiple resolutions. Nonetheless, once again, we suggest that aggregate approach offers the best chance of building a data set most representative of the total typological range. Indeed, we can gain some confidence from the fact that more recently published material, which often takes a more inclusive approach, does not seem to have produced large quantities of previously unpublished ceramic types. Despite this overall level of confidence in our data, this unspoken selectivity is something we argue that should be more explicitly addressed, especially in the contemporary environment in which larger scale databases, and to pick up from the last talk, digital storage mean that information can be provided on a larger scale than has previously been possible within the traditional constraints of printed monographs. One way of mitigating such selectivity issues is to provide a statistical overview of the contents of a deposit. While common at more recently excavated sites, like Moklos or Komos, such presentation remains rare at KNOSSOS. To some extent, this is due to the previously discussed question of discard, with some arguing that there is nothing to be gained from counting material in the retained boxes. To some extent, this is true. However, I suggest there is some value in counting selected diagnostics to build at least a crude count of shape popularity within the more commonly retained decorated pottery. Nonetheless, it remains surprising that more recent publications have not consistently used statistical information, making it hard to assess the composition of deposits. Moreover, when such information has been provided at KNOSSOS, it is often in non-tabulated or confusing formats, although such information is always useful and should become a significant part of future publications of material. Another problem that confronted our dataset construction relates to the manner in which pottery has been dated at KNOSSOS and the shibboleth of stylistic data and mixed contexts. The nature of the record is such that we've had to include material from both deposits dated stylistically and secondary contexts. Traditionally, pottery at KNOSSOS was dated through the type fossil approach, in which specific forms or styles, such as the LM2 Ephraim goblet, were considered to be representative of a single ceramic phase. More recently, and again, repeating some of what was said in the last talk and in the discussion, more recently it has been recognized that the material is not neatly compartmentalized as such an approach might suggest. Certain types have lifespans beyond their periods of maximal popularity. At KNOSSOS, and indeed elsewhere, this led to a methodological shift towards whole assemblage analysis, in which the total composition of assemblages, rather than the presence of certain fossils, is considered to reach a date. Our model, by default, given the lack of frequency data, weights all ceramic types equally, even if they might be a holdover in a period, thus aligning ourselves against the type fossil approach. However, for some periods, such as LM1b, or indeed most of LM3a, the largest groups of material are dated purely by style. Despite the weakness of this data, we argue that the effect on our data is mitigated to some extent. Ironically, the chronological fluidity of types helps our case. Even if the date of an individual piece in a wider publication could be contested, it is unlikely that purely typologically, an entire type will have been placed entirely in the wrong period. In the case of this pilot analysis, the integration of stylistically dated material does not bias our data set, given the broad analytical resolution at which we are operating. To be clear, a more developed model reliant on frequency data may not be able to integrate stylistic data quite as simply as we have been able to, but for preliminary modeling, we believe our data to be robust. As is clear from the graph, not all Knossian phases are equally well published. Certain periods, such as LM2, are particularly well known, while others, such as LM1b, have suffered. Indeed, LM1b is essentially represented by a pair of detailed preliminary reports and two small, fully published deposits. When poor contexts are excluded, this pattern is exacerbated. Nonetheless, we remain confident that the range of material is likely to be fully represented, although we urge future publication of currently unpublished material at KNOSSOS. One final point that was essential in our dataset building is the long history of chronological disputes at KNOSSOS. In general, we have followed the dates assigned to deposits by the 2007 KNOSSOS Pottery Handbook. However, we recognize that future evidence may well change how material is dated. Indeed, since the KNOSSOS Pottery Handbook has been published, much work has been done on the Middle Minoan 3A phase, dividing it into two subphases. And therefore, the possibility that future excavation may allow for new phases. As such, we constructed our period assemblages to be an amalgam of individual publications, as well as the totality of the period, so that subunits can, if necessary, be moved. Having considered these main data-related problems, let us turn to the results in the database. We've already outlined the broad features of the database, but to recap, each publication was studied in isolation, and the types were qualitatively identified and organized by surface treatment. Because we were reliant on drawings, photographs, fabric was not considered at this stage. Subsequently, the individual publications were compared to one another, and each type assigned a single code for the database, following which we built our period aggregates. By recording our information both at the level of the individual publication as well as at the period level, it means we can run our correspondence analysis at multiple levels of data resolution by flexibly removing or adding contexts or types to see whether any of the biases we have discussed fundamentally altered our model. Now for some of the results of our analysis. The two graphs show, on the left, the result of the seriation of period assemblages, and on the right, the result of what happens when we fed the individual publications into our analysis. Starting on the left, we can see that the correspondence analysis has replicated the order of periods, proving our basic point. The correspondence analysis can be used for chronology on Crete, even with a limited data set from KNOSSOS. Potentially of interest from an absolute chronological perspective is the long gap between MM3A and MM3B, which may reflect the most recent ceramic work on this, which has it as a longer period with two subphases. Similarly, the long LM1B, LM2 gap, if real, in absolute terms, reflects recent work on the LM1B period, that it seems to be a long absolute period with multiple subphases. In this regard, with its monophasal LM1B, KNOSSOS is interesting. Rutter synchronizes the Knossian deposits as being late in his stylistic sequence at Chronos, which raises broader questions of synchronization. Do we miss phases at KNOSSOS? Does KNOSSOS have a longer lasting LM1B style than other sites, adopted by the Comians late in our own LM1B sequence? These are important questions, but beyond the immediate scope of this paper. Turning to the right-hand graph, which measures deposits by their similarity to one another, the results are more complex. With certain outliers, it can be seen that the sequence between MM3A and LM2 provides relatively neat clusters of deposits, demonstrating the general integrity of these periodizations. Of interest is the fact that our analysis strongly supports the division of MM3B from LM1A, with only a little overlap in two phases that have traditionally caused a lot of scholarly bother and been hard to tell apart. This is significant as it highlights the potential of correspondence analysis beyond simply chronology, but also the possibility that we could use it to test existing conclusions and potentially generate new hypotheses. However, you may have noticed that there is less clustering for the LM3 deposits. To reiterate, at this stage in our research, we make no claim to be able to seriate individual contexts, and this lack of clustering should not necessarily be interpreted as implying deposits have been incorrectly dated. Rather, we argue, the lack of clustering with the LM3 deposits is most likely a feature of the biases of individual publications from which our aggregates were constructed, and perhaps even vindicates our choice of an aggregated approach. To fully understand why this lack of clustering has occurred, we must re-examine each individual publication in more detail to see what features caused this problem, which is something we intend to do in future. However, a few general points can be made at present. For the biggest outline, LM3A26, this represents the limited LM3A2 material from the Upper Gypsades Cemetery. The amount of pottery is very small and contains very little tableware, and a comparatively unusual range of pottery. Second, in some regards, it should be noted that LM3 sequence is particularly problematic. Many of the largest published groups, such as that from the Little Palace or South House, are heavily selected, stylistically dated evidence material. Overall, however, despite the problems with the LM3 sequence, we argue that even this graph offers significant future prospects, despite the myriad of problems relating to our data. Overall, the correspondence analysis produces several clear chronologically integral clusters. We then reran our analysis using only fine decorated tableware. This material was chosen as tablewares of the most rapidly changing ceramics and also the most reliably published. This was to test for the potential effect of discard or bias in the coarse and undecorated material through publicatory omission. We can see on the left that our chronological seriation was not affected by the unreliable data. Reducing our dataset to just decorated types still produces the correct chronological sequence. Moving to the deposits graph on the right, we can see that the ordering of publications, reflecting the degree of similarity or difference, is different to the previous graph, but we still have much the same clusters. MM3 to LM2 generally separate nicely from one another, although there is perhaps more overlap here between LM1b and LM2, which is not entirely surprising, since although LM2 is well known for its new Mycenaeanizing decorated pottery, the bulk of the decorated shapes continue from LM1, and it is the plain and monochrome pottery that undergoes the most radical transformation. LM3b does seem to present more of a cluster here than before, but LM3a remains heavily overlapped, perhaps once again reflecting the large amount of stylistically decorated material in these periods. Finally, we tested for the effect of stylistic dating and bad context by selecting only material from stratigraphically datable deposits or homogeneous closed deposits. These results are once again promising. On the left, we can see the results from the aggregate once again produce a correct sequence, demonstrating the functionality of our CA model for replicating chronology. The context graph too is much the same as before. Relatively well separated MM3 to LM1 deposits, followed by a confusion in LM3. One particularly interesting point, however, to note is the closeness of the two groups of MM3 Acropolis house deposits, which may, in the longer term, with further investigation, such as seriating the material, sorting the material more closely by type, with further investigation, help us to resolve the long-running debate as to whether this material is a single phase, whether MM3A or MM3B, or representatives of the two stages of MM3 at KNOSSOS. Overall, we believe that these three levels of data resolution clearly demonstrate the soundness of this method for further chronological work at both KNOSSOS and beyond. This paper has presented the results of a chronology-oriented correspondence analysis of Knossian pottery and explored the underlying data. Despite problems related to this data from KNOSSOS, we believe we have produced a robust dataset which works at multiple resolutions, each challenging a specific issue or quality of data. We have demonstrated the potential of using an aggregated data approach to build synthetic datasets which could be subjected to at least very basic analysis. Additionally, this paper has discussed theoretical problems that underpin and potentially undermine the creation of such datasets, which are particularly exacerbated by the highly fragmented research history of KNOSSOS. Issues such as discard, changing methodologies, contextual comparability and security, as well as authorial selectivity, all shape the record as we see it, and the dataset is produced. Well, these are all real problems and prohibit and constrain certain kinds of research. They must not be seen as roadblocks to all further research on legacy data. Instead, mitigations and workarounds of the sort presented today mean that we can still squeeze more from old material and new and valid research results. Looking forward, it is clear that further work can be done with the KNOSSOS data, for instance, by adding motif as a new dataset. However, the prospects are far broader than KNOSSOS. There are many sites on Crete with ample quantities of published data to which the method could be applied, while the restudy of bulk material and storage could create a more nuanced dataset. Despite its status as legacy data, there remains much to be learned. Thanks for your attention.
Thanks very much, Charles and Tiziano. Now, questions? And there may be questions online as well. Yeah, Tom Brogan.
So I'll ask a question that as someone who knows nothing about correspondence analysis, and I think my question is really for Tiziano and maybe Bernard. So don't worry, Charles. What causes the ordering of the data? So you already, as a pottery specialist, Charles already knows the linear trajectory of the pottery. You would then input all of this data into correspondence analysis and run this through correspondence analysis. What is the causal agent? What data input sorts things chronologically? Or maybe that's an invalid question.
I'm not sure I fully understood the question. What is
I think
causing?
my question, yeah. From a pottery expert, you order the pottery in a known way. I understand that. What is it about the program that orders the pottery in the core? What input? How is it sorting it?
The program, the way the program does the ordination is taking in account all the similarity and variabilities in the profiles, which are the profiles of the rows, in this case, the profiles of the publication or context, and the profile of types. Both every row and every column has a profile which is calculated in a matrix, and it's pretty complicated from a mathematical point of view, but basically it calculates the residuals that show how much the similar an assemblage or a category is similar to each other in the data set. And so what you obtain is actually a seriation of similarity and diversity. So that can be a bit tricky because, of course, you have to go back to the original data and see eventually what is in the different dimension, what is leading the kind of seriation. But sorry, I missed the term now. Point is that the similarity and differences profiles are those who give the order. Now, if the order doesn't fit well, it means that the development is not linear, of course, and that's something else at play. But at least you can spot it from the position in the graph of the various point, which then you go and verify what is happening there. For example, the differences in publications in the graph that the CA context graph that Charles has shown, you could perhaps have noticed that middle Minoan 3 context was far high, looking a bit of an outlier. And that, for example, is because of the kind of publication, which was different from the others. And so this basically, I think, is the answer to your question.
Do you want to explain anything more about the graphs? So we have a message from Susan Terrace at tout le monde.
Perhaps this is.
Please describe the graphs, for example, the tableware graph.
I think it's more for Charles here. Okay. So if you want to, from the ceramic point of view. Yeah.
Sit down.
I will just put the graph on.
Yeah.
Okay. Just to see. Okay. It's this works, so it's in this way.
Good.
Okay. It's
Okay.
So, as you
Not this way.
Which is right?
I think we want them to tableware.
Table.
Yes. What are the axis levels?
Tableware.
Yeah.
Okay.
Yes. What are the axis labels? Yes, I'd like to know that as well. What are the axis? That's actually what we use.
Sorry,
What do they mean?
that's it. That it's actually more difficult to explain than to know.
Well,
Actually, the axes represent the first 2 dimension. This is a multi-dimensional analysis because we have a dimension potentially for each category, for each row and each column can form a dimension. Now, the CA trick, let's say, is to isolate what more or less the principal components and to display it in a 2-dimensional graph. Now it creates a sort of space cut through a 3-dimensional cloud of points. And the 2 axes represent the first 2 principal dimensions that explain the most variability in the data set. And you can choose to put even other dimension in the axis if you want. For example, I don't have an example here, right? But it does not, the axis must not be understood as something fixed. They're just the coordinates of a slice through a three-dimensional cloud of points, and selected to display the highest variability in the dataset. I hope it's clear.
I'm sure it's clear to some. I don't. Right, I think probably one more question before we have a break. Yeah.
Exactly on that. When you say dimensions, do you mean something that is tangible, namely, say,
What do you mean by tangible?
something that's not abstract?
No, the dimensions are created by the assemblage itself. It's in extreme brutal synthesis. A dimension is all the profile of a type, the settlements, the context, or even all the types present in an assemblage.
Okay, thanks very much, both of you. And we can discuss more of this and more questions about CA, and the graphs which are unfathomable to some of us after Ero's paper, Ero and Tiziano.